So in this example we have two brackets multiplying and we want to find the coefficient of x to the power of 5. We'll take each bracket separately. So the coefficient is going to be 1, 3, 3, 1, so it's 1, and that'll be times 1 plus 3, and that'll be times 1 times minus x plus 3 times 1 times minus x all squared plus 1 times 1 times minus x to the power of 3. That's 1 minus 3x plus 3x squared minus x cubed. Then we have 2 plus x to the power of 4. So the coefficients are going to be 1, 4, 6, 4, 1. So it's going to be one lot of 2 to the power of 4 plus 4 lots of 2 to the power of 3 and x to the power of 1. 6 lots of 2 to the power of 2 and x to the power of 2 plus 4 lots of 2 to the power of 1, x to the power of 3 plus 1 lot of x to the power of 4. And we can simplify that to give, so that's 2 to the power of 4 is 16. And we've got 2 cubed is 8 times 4 is 32, that's 32x. Plus 6 times 4 is 24, x squared. 4 times 2 is 8, x cubed. Plus x to the power of 4. So we now have two brackets to multiply together. Well, what we want is the coefficient of x to the power of 5. So we don't need to multiply all the terms, just those terms that will give us x to the power of 5. So we're not going to multiply by 1 because we don't have any x to the power of 5 term in the second bracket. If I want, so I'm going to multiply, so that's an x term, x times x to the 4 will give me x to the power of 5. So it's minus 3x times x to the power of 4, that's minus 3x to the power of 5. Now, an x squared term times an x cubed term will give me an x to the power of 5, so 3 times 8 is 24. X cubed times x squared will give me x to the power of 5, so it's minus 24 x to the power of 5. Now perhaps we should remove the equal sign because strictly speaking the first and the second lines are not equal. So it's 24 take away 20, so we have minus 3x to the power of 5 then, and the coefficient of x to the power of 5 in the expansion is minus 3. Now, here we're dealing with fractions in the expansion for the first time. Let's take each bracket separately. The first one is nice and simple because we have just got a power 2. So x times x is x squared. Now, this x times 1 over x just gives us x over x. And this 1 over x times this x gives us another x over x. 1 over x times 1 over x is 1 over x squared. And that simplifies to give x squared plus 1 plus 1 plus 1 over x squared. Now the second bracket, so it's going to be 1, the coefficients are 1, 3, 3, 1. So it's one lot of x to the power of 3 minus 1 over x to the power of 0. 3 times, so we reduce the power of the x and we increase power of minus 1 over x, x to the 1 times minus 1 over x, 2, and then it's just 1 times x to the 0, I'll put the x to the 0 in, and minus 1 over x to the power of 3. So we need to simplify this now. That gives us x cubed. Now we've got I'll do this in stages, I think. So that's what the second term is. The third term is 3x times, now we've got minus 1 over x squared, which is just 1 over x squared. And then now minus 1 over x all cubed, it's going to be negative 1 over x cubed. X cubed. X squared divided by x is x, so it's minus 3x. X divided by x squared, that gives us, I'm going to write it as 3 over x, you can write it as 3x to the minus 1 if you wish. And that's what we have for the second bracket. So what we want to do now is to expand these two brackets. Got to be very careful. X squared times x cubed, that's x to the power of 5 minus 3x cubed plus 3x minus 1 over x plus 2x cubed, 2 times minus 3, that's minus 6x, 2 times, that's 6 over x, minus 2 over x cubed. 1 over x squared times x cubed is x, minus 3 over x. 1 over x squared times 3 over x is 3 over x cubed. And then we've got minus 1 over x to the 5. Let's simplify. So we've got an x to the 5 term. We've got, so there's minus 3x cubed plus 2, so that's minus x cubed. I've got 3x, take away 6x. So 3x plus x is 4x, take away 6x is minus 2x. The 1 over x term, so here is 6 over x. Take away 1 over x, take away 3 over x, that's 2 over x. 3 over x cubed, take away 2 over x cubed is 1 over x cubed. And then we've got 1 over, we've got minus 1 over x to the power of 5. So in this third example, this is a reasonably common exam type question. We have to find the term which is independent of x. Now, both the first and the second term in the bracket look quite complicated. The 6 is not a very high power, but we're certainly not going to write out all the terms. So what I'm going to do is I'm going to find a formula for the general term. So we're going to have 6r, 6 choose r, and then it's going to be 3 over 2 x squared to the power of 6 minus r, that doesn't look happy, and then minus 1 over 3r, beg your pardon, minus 1 over 3x to the power of r. So that's the general term. I'm going to have to do a good deal of work with that. I'm going to have to simplify it, because I hope you can see, here's the constant part, here's a constant part here, and we've got an x on the top and an x on the bottom here. So if we can bring these different pieces together, it will make life a lot easier. We can't do anything with the coefficient 6, choose r. So it's 3 over 2 to the power of 6 minus r multiplied by x squared to the power of 6 minus r. I hope you can see what I've done with the first term. So it's 3 over 2 to the 6 power of 6 minus r times x squared to the power of 6 minus r. Now, I'm then going to have, from the last part, minus 1 over 3 to the power of r, and what? This here is x to the power of minus 1, so I'm going to write it as x to the power of minus 1 all to the power of r. That takes us a bit further. 6 choose r. I'm just going to leave this. I'm going to move the minus 1 over 3 into that position. Now, what do we have here? So remember the powers of the rules of indices. So x to the power of 2 all to the power of 6 minus r gives us x to the power of 2 times 6 is 12, and 2 times minus r is minus 2r. And then minus 1 times r is x to the power of minus r. So proceeding, multiplying powers, we add the indices. So 6 choose r, 3 over 2 to the power of 6 minus r, minus 1 over 3 to the power of r. And that gives us, so we're going to add the two indices together, minus 2r plus minus r is minus 3r, so it's 12 minus 3r. Now if we want a term independent of x, that means we have x to the power of 0. And if we've got x to the power of 0, or if we want x to the power of 0, that means this power here must be equal to 0. So 12 minus 3r equals 0. That's a very simple equation to solve. And it means that the value of r must equal 4. So what we're going to do now is put that value r equals 4 back into this part to give us the coefficient of the term, which does not have an x. So it's going to be 6 choose 4, 3 over 2 to the power of 6 take away 4 is 2, and minus 1 over 3 to the power of 4. So 6 choose 4 is 15. The second term, 3 squared is 9, 2 squared is 4. Now I'm going to take the negative, well, it doesn't really matter. We have a negative term all to the power of 4. The negative will cancel then, so it's going to have 1 on the top. 3 to the power of 4 is 81. Now this 9 goes into 81 9 times, so it's 15 over 36. And 3 divides into both of those, so that's 5 and 12. 5 over 12 is the coefficient.